Hi, this is Team 8, Kim Hae-won, Lee Nam-hoon, Joara, Justin Chan. For about 2 weeks until last week, we introduced the panel, the facade of this building. I'll start with the review of the panel. First, the panel design through third modeling program by design team. Next, manufacturing of individual panels in the factory. And moving the panels through the trucks and cranes. And finally, fixing the panel. We explained the panel is made up of 2 layers. The outermost layer is a GFR panel, a substructure that directly supports GFR panel, an insulating panel, and a primary structure that contacts the inner panel. All of them are bolted and knotted together and assembled at the site of human hands. Below that, there is a space frame we will introduce from today. This is today's table of contents. The introduction of space frame, special structure used for flexible curved surfaces of this building and joint. Space frames are used as a substitute for regular planar buildings with traditional columns and walls. Space frames can be used to span large areas with few interior supports. And space frames allow for non-traditional designs in irregular shaped buildings, such as the Haider Al-Leif Center. They can adapt in geometry to fit many building shapes and provide an alternative to traditional buildings. Traditional buildings transfer the load through the roof into the columns, but space frames utilize every single member of the frame to always carry a load. Like the truss, a space frame is strong because of the inherent rigidity of the triangle. Every member of a space frame is constantly in axial compression or tension, allowing the load of the building to be transferred through the space frame and eventually into the foundation of the building. Although there are bending moments present in the members of the space frame, they are insignificant due to the distribution and close spacing of the members. Examples of the loads of this building is the weight loads by the internal and external structures of the building. In addition, there is also load caused by the environment, such as the strong winds in Azerbaijan and earthquakes that occur naturally around the world. Space frames are typically arranged by number of grid layers. In a single-layer grid, members of the space frame only lay in one plane, while double-layer grids have 2 and triple-layer grids have 3. The application of the number of grids depend on the area, load, budget constraints, and weight needed for a specific area of the building. Generally, single-layer grids are more lightweight and can be used for applications that have less load. However, when there are large curvatures or large loads, bending in the structure is introduced. As a result, double-layer grids can be employed to provide a stronger structure and provide more members to distribute the load evenly across the frame. Adding a second layer can greatly reduce bending in a plane. Additionally, if needed, triple-layer grids are also available for intense applications with heavy requirements. In order to increase the intensity, the triangular grid, which is the basic member, may be replaced with a square grid. Haider Al-Leif Center's apron is a large envelope area, dropping outwards from the middle of the roof area as a heavy elastic piece of cloth touching the base floor with its curved edge. For the naturalness that contacts the fluidity of the building, the apron has introduction of curved boot columns to achieve the inverse peel of the surface from the ground, and the dovetail tapering of the cantilever beams that support the building envelope. The steel flooring platforms and the intriguing steel boot columns connect with concrete walls. Due to the large span of the space frame, it is connected to the reinforced concrete structure in addition to the support of the columns and directly to the foundation in order to maintain stability of the structure as much as possible. These columns and beams increase the rigidity of the space frame, the static of glass walls, and connecting the concrete structure with the steel structure, creating a steel bridges which connecting the internal utilities in the upper floors of the buildings sporadically. Dovetail is a type of joint used to fix two pieces firmly together. It was used to make huge interior space with a small number of columns. Building an architecture is a series of connecting. In this sense, various types of connections are casting Haider-Allais Center. Among those, we're going to deal with four large categories: space frame connection, space frame and curtain wall connection, space frame and concrete structure, and lastly, connection between space frame and panel. Generally, members of space frame are joined together in three different ways. First, welding, secondly, bolting, and thirdly, threading. In Haider-Allais Center, they used threaded connection system known as marrow system. You can see the typical form of marrow connection in the yellow highlighted area. This is general fabrication diagram of space frame that used in this architecture. To give a brief explanation, 8 steel bars shape pyramid and locked up with nodes at each corner. When this pyramid unit clusters, space frame is fabricated. The node of marrow system is spherical shape with several bolt holes. Depending where the members are assembled at, the lines of space frame can draw is altered. Thanks to this aspect, the architecture was able to have beautifully fluctuating shape. Space frame works as facade or roof forging system, so it is needed place to be sat on in order to disperse the load. In this architecture, core, which is casted with RC, has the highest ability of bearing the load. Let's take a look inside. At the vertical surface of core, beams are fixed with anchor bolts, then stretches out until they meet the vertical H-beams which rise from the RC column at the ground. These two primary and secondary structures support the space frame with relatively simple connection. As space frames spread out all over the architecture, both the reinforced concrete and the cantilever beam inevitably meet space frame, helping bearing the stress from gravity and weight of the elements. To connect space frame to concrete structure and steel beam, the node of space frame needs to set the base plate up at the attached surface. Only then it can be bolted with supporting structure. The last connection we deal with is the one between structure and curtain wall glazing. In order to illustrate seamless and slick glazing surface, they hide supporting elements setting behind of the windows. As for supporting principle, the secondary structure concrete columns are vertically support, also bearing the load from the ceiling at the same time. Among those, aluminum beams set in providing stiffness against twisting as well as secure space for sticky mullion. And all these supporting structures are joined with the space frame at the end. I'll explain this in detail in the next curtain wall study. Next time, I'll take a look at the space frame in more detail and introduce the construction method. This is the end of presentation. Thank you.